Hello everyone and welcome back to Just Finish Coding. This is part 2 of our endless runner game which we're making on Scratch 3. So without further ado, let's get right into it.
Just finished coding.
Now I have to interject here that if you've not watched part 1, please watch it before you come here because as you can see I'm picking up from where I left off, and for this video to make sense you need to have watched the previous one. I will leave a card for you right here. Please watch the video and then come right back. If you're still here, then I'm going to assume that you've watched part 1, in which case let's continue with our code. So I'm going to start this off by setting up a new variable within our hero sprite, and this one is called velocity. Now remember, the main objective of this particular part is to make sure that we have the jumps and the double jumps of the cat set up, and for that it's pretty crucial that we need this variable. So I'll call it vel for the sprite only, and once you're done with this, what you can do is set velocity to 0 right at the beginning. Since obviously when the cat is right at the starting, when he's on the ground, we don't want him moving up or down. So set velocity to 0, and then the trigger basically for the cat to jump is when the up arrow key is pressed. Now there are two ways you could do this. One, you could have an if up arrow key is pressed within the when I receive tick, but that just doesn't work too well because there are too many ticks happening, and as a result we detect it too many times and we just have too many double jumps instead of a single jump when it's intended. So what's better instead is to use an event. So you can head over to events, grab a when key is pressed, and you can change this to when key up arrow is pressed. So there are going to be two cases when the up arrow key is pressed. The first case is possible when the player is currently on the ground, and the second case is when the player is up in the air. So the first case, let's deal with that first. So we'll have an if else, and to check whether the player is on the ground is fairly simple. We just check if the Y position of the player is equal to -126, which is basically default position at the starting of the game. So this is when he's on the ground, and in this case what I will do is I will make sure to change my velocity. So change velocity by 20, okay? And there is a small additional line of code that you need to add here. It's not enough that we just change y by velocity later on, but we need to change y by the velocity right here, and I'll explain why that's the case. So grab a change y by and throw in the velocity variable right into that. If we don't do this, then what is gonna happen is this condition is basically gonna stay true even the next time when we're coming in, because if we have this block in there, this condition is not going to be true the next tick. So if we don't have this block of code, this condition is going to remain true, and as a result this change in velocity just amounts to nothing. We aren't really affecting the y position by the velocity at all. So you need a change y by velocity right here to make sure that the movement gets started. And now we can get to the second case. So for the second case, we need once again a new variable. So I'm going to throw this a little bit down so that I have some space within the init, and I'm going to make a new variable. I'm going to call this jumped followed by question mark. You could call it double jumped, has double jump, whatever you want to call it. Basically this is a boolean variable, which means it has two different possible values that detect whether the player has already jumped for a second time, aka double jumped, or not. So initially what I'll do is I will set jumped to no because the player hasn't double jumped initially, and within the else statement what I will do is I will check if the jumped variable is set to no or yes. So what I will say is I will say if jumped is equal to no, then we can continue our code. But if jumped is yes, then it basically means that our double jump has already been used, and the double jump isn't going to be valid until the player drops back to the ground. So that isn't even an option to consider if this is the case. If the y position is not equal to -126, then it just means that the player is in the air and we don't want him to double jump. So in this case what I'll do is once again I will duplicate this all this code, but I will also add in a new block of code which is to change jumped, or not change but set jumped to yes, because the next time I come in when the up arrow key is pressed and the player is still in the air, I don't want jumped kept as no, because in that case the player is going to be able to double jump for an infinite number of times. The point is he has to double jump and not infinitely jump, which is why we need to set it to yes here. Alright, so that is going to be within the when up arrow key is pressed, and now we can get into the tick, because there are obviously a few modifications we need to make within the code here. So first of all, let's just make sure that the player is reset back to the ground in case he falls below the ground. So to do that, what you can do is, I think you can grab an if else and not an if. You'll start to see why. So grab an if else, and within this if statement, what you can do is grab a less than, get the Y position from the motion category, and after this you can throw in a negative 125. So if the Y position is less than negative 125, means the player is below the ground. In this case, what is going to happen is I'm going to set, head over to variables. I'm going to set my velocity. So set my velocity back to 0, because I don't want the player to, fall down any further. Then what I will do is I will set my Y position back to negative 126, so that he's back on ground level. And after this, I will set the jumped variable to no. So set jumped to no, because now he's on the ground and we have an option to double jump again the next time we jump. So basically when this is set to yes here, it's going to wait until the player is down, and after he is down, it's going to set to no, and we can double jump again. So what you have to understand is that this condition is constantly going to be true if we're not jumping. So if we're not jumping, then the Y position is going to be negative 126, and we keep repeating this code, which is basically no problem. So the second case is when the player is in the air. In this case, we want the player to accelerate when he's coming downwards. So to do that, let us change velocity by -2. And after this, you can also change Y by velocity, since the Y position needs to be affected by the velocity in some way. Now, optionally, if you want to make this a little bit more realistic, you could change it by velocity square and change it by different numbers instead to make sure it looks a little more realistic. But I mean, I'm not too bothered about that. I just want to make sure that we have a proper jump mechanism, and it's not really a simulation we're making, so I'm just going to go ahead with this. So this should work for your double jump, and I'm going to test this out right here. So as you can see, when I am testing it out, we can double jump pretty fine, and I'm going to say that this code works right here. Alright, so before I go on to the next video, what I will do is I will do a bit of setting up in my log so that it's easy for me to carry on instead of starting the stuff all from scratch. So remember that we're broadcasting two messages. One is for the initializations and one is for the game ticks to take place. So within the log, what you can first do is grab a when I receive init. In this case, first what I'm going to do is I will make sure I hide, because remember that for our log, we're going to have the log sprite itself and we're going to have a set of log clones. Now the log sprite is going to do most of the clone creating, and it's going to be the one which is working kind of behind the scenes if you want to think about it that way. But the log clones are going to be the ones which are actually physically moving on the screen and are the obstacles for the player. So we'll first hide, and remember that when we receive init, there are basically no clones that have been created yet, and as a result we're just hiding the sprite. So we'll hide the sprite, and then what I will do is I will make a new variable and I will call this clone and a question mark to show that it's boolean. Basically this tells whether this is the log sprite or whether it is one of the log clones. When we receive init, there are no clones, so what we can do is we'll set clone to no, because this isn't a clone yet. But what we must remember to do right now, I'm going to do it right away, is that when we do start as a clone, we will set the local variable, and remember that this is a private variable / local variable and it's going to differ for every single clone. But whenever we start as a clone, we will set the clone variable to yes. So now the clone is a clone, and the sprite is going to stay as not a clone. And this is very important because we're going to use this clone variable to do a whole bunch of things. So make sure you don't mess this up here. So after you've done this, you can set up a couple of more variables. I'm going to set up another one called spawn countdown. And it's important you do this for all sprites. If you do it, you could do it for this sprite only, but it's just going to be a pain. So make sure you have this for all sprites. So let me call the spawn countdown all capitals, and initially we will set the spawn countdown to be I'm going to say 80. Okay, and spawn countdown is the duration in terms of ticks, game ticks, when a new clone is going to be created for the law. Now this is going to depend on your computer's processing speed, but 80 should work if you have a pretty decent computer. Now I'm also going to make two new variables both for all sprites, which is going to give it a bit of randomness. So I'll call the first one min countdown, and I will call the second one max countdown. So make a new variable again. This time let me call it max countdown. So there we go. So min countdown is basically the lowest point of the range of which we could have possible spawn countdowns after a clone has been created, and max countdown is the upper boundary of the range where we could have a possible number of ticks before we create the next clone. So I'm just going to have an element of randomness. So for example, I'd say that the spawn countdown could be set up between hypothetically 70 and 90 initially. Those would be the min and max countdown, and the spawn countdown could be any random value between that, but it's going to be between those two. It's not going to be 95 or it's not going to be 5. So that's the general idea. I'm just giving the game a sense of randomness. Now at the beginning, I'm going to set it to those two values I mentioned. So I will set min countdown to 70, and then I will set max countdown to 90. And that is going to be pretty much it. I won't get into the actual spawning and how the clones behave. That'll probably be in the next video, and I'm going to end this video right here. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.